In the last lecture, we seen that one theorem. And what is this statement? Let V be the finite dimensional vector space over the field F, and B is the basis for V. Then there exists a uniquely determined basis B star, which is equal to F1, F2 up to so on Fn for V star. Okay, what is V star? The collection of all the linear functionals on V, such that Fi alpha j is equal to delta ij. Okay, that is equal to 0 when I is not equal to j, and equal to 1 when I is equal to here j. Okay, I is equal to j. Okay, now before going to see the examples, one definition is there: dual basis. The next definition, next topic of our syllabus is dual basis. Wait a minute. Dual basis. Okay, what is dual basis? Let alpha 1, alpha 2 up to so on alpha n, okay, be a basis. Suppose this is the basis of vector space V over F. Okay, and let small f1, small f2 up to so on small fn belongs to V star, that is collection of all the linear functionals on V. Okay, be the linear functionals defined by Fi alpha j is equal to delta ij. Okay, which is equal to 0 when I is not equal to j, and which is equal to 1 when I is equal to j. Then we can call this f1, f2 up to so on fn is dual basis for V star. Okay, then the set f1, f2 up to so on fn. Okay, in the last lecture we proved this set is linearly independent and spans V star. Okay, any linear functional we can write in the form of linear combination of f1, f2 up to so on fn. Okay, and this set forms basis for V star. Okay, and this basis the set f1, f2 up to so on fn is called dual basis. Okay, okay, or we also called as this fi, the set fi is dual to alpha j. Okay, or we also say that this set fi, okay, I running from 1 to n is dual dual for or dual to this alpha j, where j running from 1 to n also. Okay, any doubt up to here?
No, sir.
Okay, yes, yeah, basisless diamond is a dual basis of V star. Okay, now examples. Example number 1. Let R2, okay, be a vector space over R. Be a vector space over the field capital R. And if the beta or b, the basis is given to us. E1 is equal to 0, 1, sorry, 1, 0. The basis E1 is equal to 1, 0, and the E2 is equal to 0, 1. Okay, here the B is given to us. Each basis, standard order basis, is basis for R2. Then find, then find dual basis. Okay, then find dual basis. Okay, any doubt in this question? तुम्हाला बेसिस दिलेला आहे
No,
बी
sir.
स्टँडर्ड ऑर्डर बेसिस, तुम्हाला एफ डुएल बेसिस फाइंड आउट करायचं आहे, म्हणजेच काय F1 and F2. What is F1? F1 is the linear functional on the vector space R2 over R2. What is codomain?
R.
R. Okay, so this is the linear functional, and we have any linear functional. Okay, कोणताही linear transformation असेल जो R2 पासून जर R वर असेल तर त्याचा फॉर्म कसा असेल पहा. F of xy is equal to ax plus by. Okay, where a and b belongs to R. Okay, any linear functional or any linear transformation from R2 to R is of the form ax plus by. Okay, R to R असेल तर काय असणार, समजा f हा linear function आहे माझा R to R. Okay, so any linear
X.
transformation, f of x is equal to ax. Okay, हा जर x स्क्वेअर घेतला तर तो लिनियर होणार नाही. ओके, किंवा इथे एक्स स्क्वेअर इकडे वाय स्क्वेअर वगैरे घेतला की हा लिनियर होणार नाही. सो एनी लिनियर ट्रान्सफॉर्मेशन फ्रॉम R2 to R is of the form f of xy is equal to what? ax plus by. From R3 to R कसा येईल? Suppose f is the
Ax
function
plus
from,
by plus cz.
very good, f of x, y, z is equal to ax plus by plus cz. Okay, where a, b, c are any rational number, sorry, real number. ओके, जर तुम्ही ते स्क्वेअर किंवा स्क्वेअर रूट वगैरे घेतला तर ते लिनियर कंडिशन प्रूव्ह होणार नाही, लिनियरिटी होणारच नाही. Okay, so any linear function or any linear transformation from R2 to R is of the form f of xy is equal to x plus by. From R3 to R is ax plus by plus cz. From R to R is of the form f of x is equal to ax. Okay, now here we have to find the dual basis, that is beta star. We have to find f1 and f2. Now look at the proof. Now solution. Here b is equal to, what is b? E1 is equal to 1 and 0. E2 is equal to 0 and 1. Is basis for R2 over R. Okay, and supports beta star or B star is equal to F1 and F2 is basis for
B star.
or is dual basis. Write down like this. Okay, dual basis for this vector space. Okay. Okay, now we have to find what is the function f1 and f2. How f1 and f1 कसा असेल तो आपल्याला find out करायचं. Okay, then by the definition of dual basis we have, then by the definition of dual basis, what we have, dual basis, phi of alpha j is equal to delta ij, that is equal to 0 when I is not equal to j and is equal to 1 when I is equal to j. Okay, here suppose this is alpha 1, this is alpha 2. Okay, and this is F1 and F2. Okay, so we have hmm, put I is equal to 1, F1, and J is equal to 1, alpha 1. हा किती येईल याची value? 1.
One.
Is it correct? So this implies hmm, f of alpha 1 is nothing but E1, which is equal to f1 of E1 is equal to 1. Okay. Now, f1 of alpha 2 is equal to what? 0. So this implies
Zero.
f1 of E2 is equal to 0. Now, put I is equal to 2 now. f2 of alpha 1, which is equal to 0. So this implies f2 of E1 is equal to 0 and f2 of alpha 2 is equal to 1. Okay, I running from कुठून होणार? इथे I running from 1 2 and J also runs from 1 and 2. Okay, दोनच एलिमेंट आहेत तुमच्या बेसिस मध्ये. So this implies f2 of E2 is equal to 1. This is the by the definition of dual space. Okay, any doubt up to here?
No, sir.
Now let x and y be the any vector belongs to R2. Okay, be any vector then f1 of xy हा कसा असेल ax plus by. Is it correct? Any linear functional from R2 to R is of the form ax plus by. Okay, and f2 of xy is equal to, take another coefficient now, cx plus dy. Okay, any doubt up to here?
No, sir.
f1 तुमचा असा असेल, f2 तुमचं या फॉर्म मध्ये असेल. ओके, कोएफिशिएंट वेगळे असतील फक्त a b c d belongs to R. Now we have f1 of E1 is equal to 1. Okay, so this implies f1 of 1 0 is equal to 1. Okay, now put here 1 0 in f1. So this implies f1 of 1 0 is equal to h value,
A into
sorry,
1 plus B into 0 is equals to 1.
a into 1 plus b into 0 is equal to 1. So this implies a is equal to what? 1. Okay. Now similarly, now f1 of E2 is equal to what? 0. So this implies f1 of 0 1. What is Z2? 0 1. Now put 0 1 instead of x is 0, instead of y is 1 in f1. Okay. So what we have? 0 into x plus 1 into y, which is equal to 0. Okay, why 0? Because f1 of 0 1 is 0. Okay, so here we get, sorry, this is p now. Wait.
B into 1.
Wait. Here a into 0 plus b into 1 is equal to 0. So this implies b is equal to 0. Any doubt?
No, sir.
Okay, actually x and y have put color. Similarly, find c and d. Okay, what is f2 of E1 is equal to what? What we have? 0. So this implies f2 of 1 0. E1 म्हणजे तुमचं काय? 1 0, which is equal to 0. So this implies c ची value 1. c into 1 plus d into 0 is equal to 0. So this implies c is equal to 0. Okay. Now f2 of E2 is equal to 1 by the definition of dual basis. So this implies f2 of 0 1 is equal to 1. This implies what we have, c into 0
D is equals to
is d into 1 is equal to 1. So this implies d is equal to 1. Now putting the values of a, b, c, d in f1 and f2. Hence, f1 of xy. What we have? Ax plus by, which is equal to x. Okay, h value 1 is, and f2 of xy is equal to cx plus dy, which is equal to y. So this implies f1 of xy is equal to x, and f2 of xy is equal to y. Now look at here. इथे इनपुट दोन आहेत तुमचे, आउटपुट किती येतोय? एकच येतोय. So hence this is the f1 and f2 is the functional from R2 to R, which is linear. Okay, so hence f1 and f2, hence the dual basis is f1 of xy is equal to x, comma f2 of xy काय असेल तुमचं y. Any doubt?
No, sir.
ओके, तुमचा फंक्शन काय असेल हा f1 xy ला, xy कुठे ट्रान्सफॉर्म करतोय x ला. ओके, आणि f2 of xy काय कुठे ट्रान्सफॉर्म होतोय y ला. Okay, now next example is second one. If the basis b is given as minus 1 1 1, okay, 1 minus 1 1, and 1 1 minus 1 is a basis. कोणाचा basis?
R3 over R.
Okay, v3 over r, or we can say that v3 over r. Then find the dual basis. Find the dual basis of p. Okay, या basis था दूसरा basis, dual basis. Now answer. Let write down the bit, the basis p. This is alpha 1, which is equal to what? Minus 1 1 1. Alpha 2 is equal to 1 minus 1 1, and alpha 3 is equal to 1 1 and minus 1. Okay, be a basis of v3 over r, or r3 over r. Okay, now let p star is equal to f1 f2 and f3. ओके, जेवढे वेक्टर्स तुमचे बी मध्ये असतील तेवढेच बीटा स्टार मध्ये असतील, बी स्टार मध्ये असतील. ओके, बी ए डुएल बेसिस, बी ए डुएल basis, then by the definition of dual basis, by the definition of dual basis, now look at here. What we have? f1 alpha 1 is equal to 1, f1 alpha 2 is equal to
0.
f1 alpha 3 is equal to again 0. Now f2 alpha 1 is equal to 0, f2 alpha 2, जेव्हा I is equal to j असेल तेव्हा 1, जेव्हा I is not equal to j then 0. Okay, f2 alpha 3 is equal to 0, f3 alpha 1 is equal to 0, f3 alpha 2 is equal to 0, and f3 alpha 3 is equal to 1. Okay, now put alpha 1 alpha 2 in alpha 3. Wait a minute. Let, before going to that step, let x y z be the any vector belongs to v3 over r. Be any vector. Okay, now let us assume the any linear functional or any linear transformation from R3 to R is of the form Suppose f1 of x, y, z is of the form a1x plus a2y plus a3z. Okay, and f2 is again linear functional x, y, z is equal to b1x plus b2y plus b3z, and f3 of x, y, z is equal to c1x plus c2y plus c3z. Any doubt up to here?
No, sir.
Okay. First determine f1. Okay, put alpha 1, alpha 2, alpha 3. We get three equation in three unknowns. Okay, put alpha 1, alpha 2 and alpha 3. F1 alpha 1, 1. F1 alpha 2, 0. F1 alpha 3 is again 0. So here we get three equation in three unknown. Okay, मी एक सॉल्व करून दाखवतो, बाकी तुम्ही सॉल्व करा. We have f1 alpha 1 is equal to 1. What is alpha 1? 1. काय alpha 1?
-1, 1.
Minus 1, 1, 1. Okay. Minus 1, 1, 1. Hmm. Put alpha 1 here. So here, f1 of minus 1, 1, 1, which is equal to minus a1, okay, plus a2 plus a3 is equal to
1.
1. f1 of 1 minus 1, 1 is equal to now. Okay, f1 of alpha 2. f1 of alpha 2 implies is equal to 0. Okay, this implies f1 of 1 minus 1 is equal to a1 minus a2 plus a3, which is equal to 0. Okay, now write down f1 of alpha 3 is equal to 0. So this implies f1 of 1, 1 minus 1 is equal to a1 plus a2 minus a3 is equal to 0. Okay, now we have three equations in three unknowns. Will solve करता
Yes, sir. Yes, sir.
minus a1 plus a2 plus a3 is equal to 1. Okay, this equation, first one. First equation. And the third one, a1 plus a2 minus a3 is equal to 0. Okay, यांची काय करावी लागेल? Addition करू. This gets cancelled. So 2a2 is equal to 1. So this implies a2 is equal to 1 by 2. Okay. Now a1 plus a2 minus a3 is equal to 0. Okay, third one. And a1 minus a2 plus a3 is equal to 0. Again add these two equations. This get cancelled. And 2 a2 is equal to 0. So this implies a1, sorry, a1 is equal to 0 and a1 is equal to 0. Okay. a1 ala. Okay. So here we find a2 and a1. Now we have to find the value of a3. Put a2 and a1 in any equation. Okay. In any one of the equations. So we get a3 is equal to 1 by 2. Is it correct?
Yes, sir. Yes, sir.
Okay. Now similarly, f2 of alpha 1, 0. f2 of alpha 2, 1. f3 of alpha 3, we get 0. Again, we get three equations in three unknowns. What are the unknowns? b1, b2 and b3. Okay. Similarly, f3 of alpha 1 is equal to 0, f3 of alpha 2 is equal to 0, and f3 of alpha 3 is equal to 1. We get three equations and three unknowns c1, c2, and c3. Okay, we solve it. Now, similarly, we can find b1 is equal to 1 by 2, b2 is equal to 0, and b3 is equal to 1 by 2. And c1 is equal to 1 by 2, c2 is equal to 1 by 2, and c3 is equal to 0. काही डाऊट आहेत का याच्यात? येईल ना सॉल्व करता?
Yes, sir.
Okay, so hence f1 of x, y, z, x, y, z is equal to what is a1? A1 is 0. Okay, look at here. A1 0, A2 1 by 2, A2 1 by 2. So x coefficient are into the 0. So here 1 by 2 into y plus 1 by 2 into z. Okay, that is equal to what? Y plus z divided by 2. F2 of x, y, z is equal to b to 0. Okay, so here x plus z divided by 2. Is it correct?
Yes, sir.
F3 of x, y, z is equal to y plus z, x plus z, x plus y equal to divided by 2. Okay, so these are the three linear functionals. Okay, and this set forms the dual basis for dual basis of B. Okay, hence B star is equal to F1, F2, F3 forms dual basis. Okay, any doubt up to here?
No, sir.
No, sir.
Okay, definition लक्षात ठेवा. Okay, so we will move towards the next theorem. Okay, let capital V be a finite dimensional vector space over the field F. Okay, हे statement प्रत्येक theorem ला common आहे. Let V be the finite dimensional vector space over the field F, and let okay finite dimensional काय म्हटलंय? R over Q. Finite dimension आहे का? This vector space is finite dimension or not? What is the dimension of this space?
1.
1.
1. Now,
2.
2.
now, okay, in between R and Q there is infinite field.
Yes,
शिकलो
sir.
नहीं? Q root 2, Q root 3. Okay. So here let V be the finite dimensional vector space. म्हणजे हे सगळे रिजल्ट्स ते कोणासाठी लागू होत आहेत? Finite dimensional vector space. Okay, let V be a finite dimensional vector space over the field F, and let जर तुम्ही इन्फायनाइट डायमेन्शनल घेतला असेल तर त्या बेसिस मध्ये तुमच्या फायनाइट एलिमेंट आलेच नसते. ओके, so here B is equal to alpha 1, alpha 2 up to so on alpha n be a basis for V, be a basis for capital V. Let B star is equal to F1, F2 up to so on Fn. Okay, be dual basis of V star. Then for each linear functional, each linear functional ओके, फंक्शनल म्हटलं की तुमचा कोडोमेन फील्ड असतो. ओके, each linear functional f small f on capital V we have. Okay, हे तुमचं सगळं स्टेटमेंट अँड वी हॅव टू प्रूव्ह दॅट f is equal to small f is equal to summation I running from 1 to n f of alpha alpha I into fi small fi. Okay, and for each vector alpha, for each vector alpha in capital V, we have one more statement we have to prove. Alpha is equal to summation I running from 1 to n fi of alpha into, wait a minute, alpha I. Okay, रिवर्स आहे बघा, इथे जिथे जेव्हा जर एफ असेल तर अल्फा इंटू एफ आय, अल्फा असेल तर अल्फा इंटू अल्फा. ओके, इथे आय येतोय. ओके, पहा स्टेटमेंट काय सांगतो. Let V be the finite dimensional vector space over the field F, and B is the basis for the vector space V, and B star is the dual basis for V star. Then we have to prove that for each linear functional on V, F is equal to summation I running from 1 to n. F, we can write F is equal to linear combination of F into alpha I, sorry, F of alpha I into Fi, and alpha for each alpha in V. Okay, each and every vector in capital V, we can write alpha is equal to summation I running from 1 to n Fi of alpha now. Okay, into alpha. दिसायला दिसतं अवघड पण खूप सोपं आहे. पहा प्रूफ. Let write down all the given things. Let B is equal to alpha 1, alpha 2, up to so on alpha n. Be a basis for V. Okay, capital V. Let B star is equal to F1, F2, up to so on Fn, be a dual basis of V star.
Restart.
For V star. Let small f be any linear functional on V, any linear functional on capital V. We have to prove that this f we can write in the form of summation I running from 1 to n f of alpha I into fi. Okay, first statement. First one, since B star is basis of V star. Okay, then we can write any linear functional from V star, f is equal to summation I running from 1 to n ai into fi. Is it correct? कोणताही एक function from V star we can write in the form of linear combination of basis element. Okay, this ai belongs to the field F. Okay, by the definition of basis. Okay, डेफिनेशन ऑफ बेसिस, बेसिसचा डेफिनेशन जर बेसिस असेल आणि कोणताही एक एलिमेंट घेतला तर तो काय करू शकतो, लिनियर कॉम्बिनेशन ऑफ बेसिस एलिमेंट वी कॅन एक्सप्रेस युनिकली. ओके, एनी डाउट अप टू हियर?
No, sir.
Okay, so write down this is equation number 1. Let us operate this functional on alpha j. Let us operate. Alpha j on both sides. Okay, so what we have, f of alpha j is equal to hmm, summation I running from 1 to n ai into fi. Okay, ai into fi of alpha j. Is it correct? Now, this is equal to summation I running from 1 to n ai into fi of alpha j. Okay, which is equal to summation I running from 1 to n ai into delta ij. Is it correct?
Yes, sir.
Okay, fi alpha j म्हणजेच काय तुमचा chronicle delta delta ij, which is equal to, now run I, okay, from 1 to n. So this is a1 delta 1 j plus a2 delta 2 j plus up to so on aj delta j j plus up to so on a n delta n j. Okay, in between I and n तुमचा कुठेतरी j असेल. ओके. आय रन केलाय मी फक्त 1 to n पासून 1 2 3 up to so on j and up to so on n. Is it correct?
Yes, sir.
Okay, हा तुमचा काय आला f of alpha j. So this implies f of alpha j is equal to what?
AJ.
aj only. Okay, now put this value in equation number 1. What is aj equal to equation 1? जर aj जर माझा हा असेल तर काय होईल, फक्त इंडेक्स बदला फक्त खालचा. f of alpha is equal to ai. Okay, so this implies from equation 1 हे काय येईल तुमचं, f of alpha is equal to काय ai. Now put the value of ai in equation 1. So this implies f is equal to summation I running from 1 to n. हा वेरी हे काय तुम्हाला इंडेक्स आहे, फक्त सफिक्स आहे. ओके, हा बदलू शकतो आपण. So f is equal to summation I running from 1 to n. What is the value of ai? F of alpha I into fi. Hence the proof. Any doubt?
No.
Now
No,
the
sir.
second step now. Let alpha be any vector. Okay, alpha be any vector. Now we have to prove that alpha we can write in the form of summation I running from 1 to n fi of alpha into alpha I. Okay, so write down this is equation number 2. No, this is not 2. Now, since V is basis for V, okay, vector space V, and alpha is any vector belongs to V. By the definition of basis, we get hence alpha is equal to summation I running from 1 to n ai alpha I. Correct? Is it correct?
Yes, sir.
ai belongs to capital F, the field F. Now consider fi of alpha is equal to what we have in fi. What is alpha? Summation I running from 1 to n ai alpha, sorry, alpha I. Okay, so this is fi of alpha is equal to fi of a1 alpha 1 plus a2 alpha 2 plus up to so on. This is an alpha n. Okay, so fi of alpha is equal to fi is what? Linear functional. Okay, म्हणजे हा तुमचा linear transformation. So by the definition of linearity, we have a1 fi of alpha 1. Okay, plus up to so on. In between 1 to n तुमचा हा I कोणाशी तरी मॅच होईल इथे. Okay, so ai fi of alpha I plus up to so on an fi of plus an fi of alpha n. Is it correct?
Yes, sir.
Okay, I running from 1 to n. Okay, आपल्याला हा I तुमचा इथे in general. Here I is in general. Okay, so in between 1 to n, this I coincide with one of them. Okay, so this implies fi of alpha. Okay, is equal to, by the definition of dual basis, what we have, this one is 1. Okay, so this is ai. Now put the value of ai in equation number 2. Okay, so what we get from equation 2, we have fi of alpha is equal to, sorry, from equation 2, alpha is equal to summation I running from 1 to n, instead of a fi of alpha into alpha I. Hence the proof. Any doubt up to here?
No, sir.
Okay, so one note is there. After that note, we will stop here. Okay, the remaining part we will see in the next lecture. What is not? If V, capital V, is finite dimensional vector space over F, okay, then this B is isomorphic. This B is isomorphic to its dual space or dual basis. Dual basis V star. Okay, if V is the finite dimensional vector space, then B is isomorphic to what? V star. Okay, all the properties of B satisfied by B also satisfied by B star. Okay, any doubt up to here?
No, sir.
Okay, so we will stop here. The remaining part we will see in the next lecture.